Hey guys, it is Whine here, and today we are talking about shapes of curves questions, but the miscellaneous ones. So first off, if you aren't familiar with the shapes of curves rules or want to go over some more general shapes of curves questions and information, definitely check out the other shapes of curves videos first. These questions are kind of like the miscellaneous, weird, like rarely asked questions. They deal with the shapes of curves rules, like concave up, concave down, increasing, decreasing, but in a very odd way. So if you aren't familiar with the rules or you want a more standard place to start, definitely check out the other videos first. The questions that are asked on this worksheet are like, if you're taking AP Calculus, it'll be like maybe one or two multiple choice questions. Not a super big deal, but we just want to make a comprehensive program. So we're still going to teach you guys, but bottom line, these are not the most important questions to focus on, but we still want to teach you guys everything that might be on the exam. So we'll start with number one. So if you read number one, oh, by the way, worksheet and answers are in the description, so if you want to follow along, please do. Yes. Okay, so anyway, back to number one. Number one is really asking about the relationship between a tangent line, which is L of x, and the actual function, which is f of x. So in this instance, you're looking for a case where the tangent line, L of x, is less than or equal to the function, L of x. So the way I'm going to demonstrate this is to draw out a function for each of these, and then, so we have to find a function in which, I know it asks at -1, but the way to really test this is to find a function where any tangent line will be below the function, or less than, which institutes below. So because you don't know where -1 is going to be on the function. I mean, that can be depending on what the function is, and we don't know what the function is. So really, we need a function where every single tangent line is below the function. So in instances A and B, because we're just testing the first derivative, f prime, I did like a cubic function. And then for C and D, because we're testing concave up, or we're testing the second derivative, which is kind of concave up and concave down, I just did parabolas. So as you can see in A, my finger's in the way. You can draw a tangent line both above and below a cubic function. So A and B probably is not going to be right because you can overestimate, or you can have a tangent line that's above the function. So that's not really what we're looking for. And C, as you can see, these tangent lines are always above the parabola. So the correct answer is D, which shows that these tangent lines are always below the function no matter where you draw them. They will always be below. And this hints to a greater idea in that concave down functions tend to overestimate like if you're looking at a tangent line, concave down tends to overestimate what you're looking for, and concave up tends to underestimate what you're looking for. As you can see in this case, concave up underestimates because the tangent lines are always below, and this one overestimates because the tangent lines are always above. So that probably doesn't make sense right now, but we're actually going to come back to it in a different question on the worksheet. So just keep that in mind. But as you can see, hopefully the correct answer is D, because D is the only instance in where the tangent line has to be below the function. See, on A and B it could be, but depending on what the function is, it could also overestimate, and we want something that's going to be or greater than, and we want something that's going to be always less than, so that has to be a concave up function. Sorry, the paper is a little crooked. So moving on. See, as you can see, these questions are really kind of weird. They're strange. They are asked in a weird way. So that's why these questions are kind of the last thing you learn. They're not, I don't want to say the least important, but they're definitely ones that are more important. Like, this is never going to be in a free response question, or it's never going to be more than one or two multiple choice. So really learn how to do these, but don't make them the biggest focus of your time. So sorry, I'm going to go back to number 2. Starting with number 2, so the table below gives certain values of f of x, of the function, and the function f is differentiable, and we know that f double prime of x is positive. So we need to figure out what could be a possible value of f prime of 2. And the best way we're going to do this is we are going to calculate rough f prime values. And we can't do this in a calculus way, like we don't have a function that we can take the derivative of. So we're going to go back to the good old algebra fashion of finding a slope, y minus y over x minus x. And so this is definitely an approximation of the slope. It is not 100%, but it's the best we can do right now, and it will answer the question. So I'm definitely going to draw it out, but I just wanted to explain what we're doing. Once again, this is the algebra slope. It is not the calculus slope, but it is the best we can do, and it'll definitely answer the question for us. So that is what we're going to do. So like I said, y minus y over x minus x. And so this is just me writing it out. You definitely don't have to. It's simple algebra, but just to make things clear for you guys. So I will stop here. So we found that the slope between the x values of 0 and 2 is approximately 1, and I meant the f prime value. I don't know what I said. And then the f prime value between 2 and 4 is approximately 2. So if we're looking for the possible value of f prime of 2, we know that it has to be in between 1 and 2, right? Because 2 is kind of in the middle of this right here. So we want something that could be in between that. And so the only answer for that could really be B. Oh, wait. Yeah. Oh, excuse me. Oh, and this is just me explaining it more. So because we know f double prime is positive, we know that f prime is constantly increasing. So we know that the number in between, the number has to be between 1 and 2. It can't go from 1, jump up to 3, and back to 2, because we know that f prime is always increasing. So we have to know that x is in between 1 and 2. Sorry, I skipped through that. But just a little recap. One of the shapes of curves rules. Once again, if you're not familiar with the rules that I'm citing, you definitely want to go check out another shapes of curves video, a more standard one. But because we know that f double prime is always positive, we know that f prime has to be increasing, and so x has to be in between that 1 and 2. Sorry I jumped through that in the first part of the explanation. Moving on to number 3. I probably move myself so you guys can completely see it. Excuse me. So if we know that f prime is always positive, we know that f, or the function, is always increasing. And if we know that f double prime is always negative, we know that it's concave down, but we also know that f prime is always decreasing. So that's what we're going to be using to solve this question. So first, we'll start off with the first piece of information we're giving is that f is always increasing. So we know that f of x has to go up as the x values go up. So I took the liberty of crossing off a, because in that case f prime is not increasing, it's just staying flat. It's a horizontal line, which is not what we're looking for. That doesn't match the shapes of curves rules that we're talking about. So a doesn't work because it is not increasing. And then if you guys keep looking at all the answer choices, you can also see that D also does not work because f prime is actually decreasing in this case, or f is decreasing in this case. which doesn't make sense because f of x has to be increasing because of the rule that f prime is positive. So now that we've narrowed it down to b and c, we're going to do the same thing we did on the previous problem, and that is to approximate the f prime values using the algebraic slope. We're going to do this to see in which case f prime decreases, because as you guys remember, that rule right there, f prime of x has to decrease if f double prime of x is always negative. So we're going to see in which case it is decreasing, and that'll give us our answer. So we're going to use the algebra slope like I said, just like we did last time, simple algebra. And in this case, it's actually even easier because the x values are only 1 apart, so it's really just y minus y. I wrote it out to make sure you guys could see what I was doing though, but you definitely don't have to. And then we're going to do the same thing for c. We're going to find those f prime values, the algebra ones, but those are close enough to approximate the calculus ones, so it works. And we need to find the one in which f prime of x is decreasing. And as you guys can hopefully see, that would be case C. B is incorrect because f prime of x is not decreasing, it is increasing from 1 to 3. Excuse me. Cool. All right, number 4. We know that the function is continuous on a closed interval. It's twice differentiable. We know that f prime of 0 equals 1 and that f double prime is always positive. So we need to figure out which of these tables matches that description. So as we know, if f double prime of x is positive, that means that f of x is increasing. Once again, if you don't know these shapes of curves rules that I'm referencing, please go watch the other videos. They explain the rules more and they are giving more standard questions. Like I said, these are kind of not super standard questions. They're rare, but they're going to be on the exam, so you might as well know how to do them. I don't know why I'm taking so long to write this. Let me fast forward a little bit. Okay, so what we're going to be doing is we're going to be, like we've been doing in the last 2 problems, approximating the f prime values algebraically using slope y minus y over x minus x. And I'll fast forward through these because you guys can see what I'm doing, and I'm sure you guys can do algebra pretty competently. I trust you guys. And we couldn't really eliminate any on the front end like we did with number 3, so we're going to have to do it for all 4 columns, sadly, but that's okay. Doesn't take too long. And feel free to pause if you need to catch up or anything. I just really can't fill the void. Oh, sorry. I just really can't fill the void with me talking through all of that. I don't want to bend your ear with all this random algebra stuff. Okay, so as you can see, I crossed off D. And the reason I crossed off D is we found the approximate f prime values using the algebra slope. And as you can see, in this case, in chart D, the f prime value is decreasing. It's going from 1.5 to 5, which doesn't match this rule right here. So that is not an answer choice, or that is not the correct answer, so we're crossing that out. Sorry, I kind of wrote off the screen, but it says that f prime is not increasing. So that cannot be correct. There we go. Okay. So now we have to, since all the other ones are increasing, we kind of have to narrow down the answer even more. But luckily we're given another fact that f prime of 0 equals 1. So what does that mean? So kind of, what question was it? Kind of like in question number 2, I think, we're given the fact about the x value right here. So if we know that f prime of 0 equals 1, and we know that f prime is always increasing, then we know that 1 has to be between the two values of f prime that we found. And the reason we know that is because 0, the x value, is in between these, like, I don't really know how to describe it, but because the two intervals are, we'll use chart B, but it's the same x values for all of them, because 0 is in between the two ranges of -1 to 0 and 0 to 1. So we know that 0 is kind of right in the middle of those two ranges, so we know that the f prime value of 0 has to be in the middle of the two f prime ranges that we've already found. Hopefully that makes sense. So now we know a way to narrow it down. I'll start the video again because I think I draw this out a little bit. So as you can see, 1 is actually a value in both charts A and C, which means that if f prime of x is constantly increasing, 1 can't be in the middle of those two ranges because it's on the beginning and end of those two ranges. So that doesn't make sense, so we discover that the answer is actually B, because 1 can kind of fit right in the middle of 0.5 and 1.5. I drew that really poorly, so I kind of just drew a star and kind of tagged it right there. But 1 is in the middle of 0.5 and 1.5, so it works. So that is the correct answer, B. Okay, moving on to number 5. So number 5, kind of a little bit of a more complicated question. These always kind of, here, I'll move this up so you guys can see. You'll just have to see my slider bar, I'm sorry. This question always kind of confused me when I was taking calculus, just because it took me a minute to wrap my mind around. So hopefully I can talk through this pretty slow and explain it. This is one of those questions that is more likely to be on the exam, but we can do it. I understand it now, don't worry. Okay, so let f be a differentiable function, and that f of 1 equals -2, and that f prime of x is greater than or equal to -3. So which of the following is a not possible value of, what value are we looking for? F of 3. I'll move this up a little more. Okay, so the way we're going to solve this is we're actually going to draw it out. We're going to draw a picture. We're going to start at 1, -2, and then actually draw a line up to the x value of 3 and see what y value corresponds with it and what y values are possible and not possible. And the way we're going to do this is we are essentially given a slope. We're given a slope through the f prime value, because remember that's slope. And in this case, it says greater than or equal to, but we're just going to say it's equal to right now. So we're just going to assume the slope, or m, is 3. And so we're actually just going to draw it out. So we're given 1, -2, so that's where we're going to start. And then we're given a slope of 3, of -3, excuse me. Sorry. It should be -3 with the m, but it says -3 in the problem. So that is our f of 3. So it's 3, what's that? 1, 2, 3, 4, 5, 6, 7, 8. So it's 3, -8 is the point we're given. So do not go and jump on the answer -8. That is an option, but it is not the right option. So now we have a line. But we need to figure out what's not a possible value. And in order to do this, we need to figure out on what side of the line is possible values and on what side of the line is impossible values. And that is where that greater than or equal sign comes into. Remember, we assumed that the slope value was just equal to 3. That is not what the problem says at all. It says that it's greater than or equal to. So, I know I draw it out, but I'm taking a while. So I'll speed up to when I draw it. Okay, so I'll pause it right here. Okay, so as you can see, I drew that on the right of the line, or on the upper side of the line is possible, and then below the line, or on the left side of the line, is not possible. And the way I gathered that is, as it says, the f prime of x is greater than or equal to. So if it's greater than, then that means this slope can also be -2, -1, or even a positive slope, or 0, or even a positive slope. So that line, the way I always imagine this is going to be goofy, I'm sorry. So if this is the, I guess the line, if this is the line, that kind of matches the line, right? Then anything, sorry, my camera's flipped, so it's kind of weird. So anything on this side of the line is possible. That line could swing up, and actually anything on the upper side of that line is possible because that slope could be greater than -3. I hope I demonstrated that well, but I literally just imagine the line just kind of like, here, I'll even draw it. I even always just imagine this could be the line. I'm so sorry, that's awful. This could be the line. 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 So any of these values are possible because their slopes are all greater than -3. The only the only lines that aren't possible are lines that have values that are greater than -3. So -4 is not possible. -5 is not possible. Like, all of these are just not possible. Because the slope's greater than -3. So, so as you can see, all of these values, -8, -2, and -1 are possible, and the only one that is greater, so we're looking for a value that's greater than -8, right? -8 is kind of the bookend of all the possible values, and the only one that's greater or less than -8 is -10. I say greater because, like, the slope would be larger. Well, not, the absolute value of the slope would be larger. Sorry, it's really weird terminology with all the negatives, but it's on this side, it's on the left of the line, so it is not possible. Another kind of sneaky way you could think about this is once you find, this is so bad, I'm sorry, but once you find the -8 value, once you find the m, where you, the point that you find that kind of bookends the line, there's going to be the answer choices are going to be that value, and then either 2 values above that value or 2 values below that value, and then the last answer choice is going to be the answer that's the other 2 are not. So in this case, you have -8, which is the real value, and then you have 2 that are above it, and then 1 below it. And the answer, and it's always going to be what is not a possible value. So I always consider these 3 values, they're all the same. Like, they're all on one side of the line, and this is the only one that's on the other side of the line. So even if you get confused with the possible, not possible side of, even if you get confused on which side is possible and which side's not possible, there's always going to be the actual value, the slope point that you found, -8, and then there's going to be 2 that are either above it. In this case, it's above it, -2 and -1, and then 1 that's below it, -10. Or if it was the other way, it'd be -8, and then if you were looking for something, like if the slope was less than or equal to -3, it would be like -10, -11, and then -1. And the -1 is the different answer So that's the one that's not possible. I hope I explained that well. The more problems you do like this, you'll definitely recognize that pattern. So kind of keep that in mind. If you get confused, always just look for the different answer. Yeah, sorry. Hope that helped. All right, number 6, moving on. Sorry. Okay, so we're looking for, so the function is twice differentiable, has no points of inflection, which means it doesn't change concavity. And we have a couple of points that we're given. So we're giving f of 3 equals 4, f prime of 3 equals -1, and f double prime of 3 is -3. And we're looking for the possible value of f of 4. In this case, we're also just going to draw another picture. I don't know why it takes so long. Sorry for that really ugly coordinate plane. Okay. Anyway, so we're given, remember, we're given f of 3 is 4, so I just plotted that point. And next we're given that f prime of 3 is -1, which is the approximate slope. So we're going to use that approximate slope to get to f of 4. So it's really just -1, so down 1 over 1. And then finally, and we did f of 4 because that's what we're looking for, by the way. If it was f of 5, we'd go down 1 more. And finally, we're given that f double prime of 3 is -3. And what this is really good for is concavity. So we know that this is concave down. So I just drew a rough concave down function through those 2 points to kind of visualize what I was looking at and kind of visualize the problem. So, and this is the question that relates back to the first question, in which I was like, concave down over approximates and concave up under approximates. Remember when I talked about that, guys? It was literally number 1. So anyway, so as you can see, now I am, so we have the value, let me back up. Okay, so we have the value 4, 3. So, 3 is kind of the -8 in this situation. So if you guys can pick out what answer choice is different, that would be the right answer. But if you want to go about it the correct way, I will explain it. The answer that is different, remember, either 2 values are above and you're looking for one that's below 3, or 2 values are below and you're looking for the value that is above 3. So that's kind of how to cheat. Okay, but anyway. So the value is 3 is kind of our -8 in this situation. And I'm drawing these tangent lines to show that these tangent lines are, no matter how you draw them, are going to overestimate the value. And so that really tells us that 3, that value that we found, is an overestimate of f of 4. So we need to choose a value that is below f of 4, which in this case, the only one available is 2.5, or a. So tangent lines for concave down functions always over approximates or overestimates the values. So we found 3, but we know that 3 is going to be a little too big, so we need to choose the one that's below 3, which in this case is a. So it needs to be less than 3, which is a. Okay, moving on to the last 2 questions. These are literally what I call the stupid questions because I think they're stupid. Because they don't really test math, they just are like nitpicky. But we're going to work them anyway because they might be on the exam. I hope they aren't. I don't know. I think they're stupid. Okay, anyway. done with me ranting. So f of x is a continuous and differentiable function whose f prime values are given on the interval below. So which of the following statements must be true? Must be true. So I think I start with statement 1, which is that f has a relative minimum at x equals -1. So that means that, here, I'll slide it over so you can see. So that means that f prime of x goes from negative to positive. So it looks like it does, right? So if we're looking at -1, that's the 0, and it goes from negative to positive. So that makes sense, right? Wrong. Because we don't know the values in between -2 and -1. See, it could go from -3 to 4 to 0 to 2. So it might actually be not. And that's why I think this is stupid. Because they nitpick because it looks like it's right, but we technically don't know the values in between the numbers given in the table, so it could be wrong. So that's why I call these stupid. This question can turn into a non-stupid question if there's a sentence in there that says a sentence that addresses the values in between the values in the table. So if it says in the question, if it says the values from -1 to 5 are constantly increasing, then we know that the values in between those two points are always upward. So there can't be a random relative min or max. There can't randomly cross 0. It's just stuff like that. So if it does address the numbers in between the values that are given, that's great. If it doesn't, always keep those numbers in between the values given on the table in mind, because that's what they're asking. I don't know why. Okay, moving on to statement number 2. So statement number 2 says that f prime is positive for x in between 1 and 5. So that means that the actual function is increasing. And that looks like it's right? Because it goes 1, 2, 5, the f prime of x goes 2, 4, 7. But once again, you don't know the numbers in between the given values, and it could skyrocket in between and look like a big zigzag. And there could be a random negative number in there, and we don't know. So technically, it is not right. So technically, the answer is D, neither. Stupid, right? I'm sorry. Moving on. Number 8, I think this is another stupid one. Okay, so f of x is continuous and differentiable, whose f prime values are given. So I think I start with A. So A says that f is increasing on 3 to 4. Makes sense. On the x, it goes from 3 to 4. On f prime, it goes from 4 to 7. It's positive, so we think it's increasing. Once again, I'm sorry, we don't know the numbers in between 3 and 4. We don't know if 3.5 is -4. Could be, we don't know. So that is technically wrong, because we don't 100% know the numbers in between. So we don't absolutely know that it's increasing. Stupid. Moving on to B. F is concave up from 0 to 4. So that is basically saying that f prime is increasing from 0 to 4. Sorry for that mistake. If f is increasing, then f prime is positive. It does not have to be increasing. For f to be concave up, f prime has to be increasing. And it looks like it is, because it goes from -2 to 4 to 7. Once again, we do not know the numbers in between the values that are given in the table, so something could be weird and unexpected in between the values, so could be wrong. It could go from -2 to -3 to 4, which in that case is not concave up for the whole span. And now I'm going to skip C, because that's actually the right answer, and I'm going to move on to explain why D is wrong. So D says that f has less than 3 relative extrema on the interval. So relative extrema means that f of x crosses 0. or crosses the x-axis. So it looks like it crosses right here, right here. So that's less than 3 because it's 2, right? Looks right, looks right. Once again, stupid question. We don't know the values in between. There could be a random crossings of 0 in between 3 and 4, between, there could be another random relative extrema. So that could be wrong. Let me move it down so you guys can see what I'm writing. Sorry, you can see my slider. Oh, there. Okay. So now we know that C is right by process of elimination, but let me explain why it is right. It is right because it says at least one inflection point. So an inflection point means it means that f of x changes from increasing to decreasing. So it does that, right? And where does it do that? Like right here. Changes from, or wait. It goes from -3 to 1, so that's increasing, and then it changes to decreasing because it goes back down to -2. That's an inflection point. Sorry, I had to review those rules. But anyway, so that is right. It has at least one, but it could have more than one that we don't know about because of the random numbers that possibly are in between the given values. So it could be more than one, but that's okay because it just says at least one, and we can prove that there's at least one. There may be more. So really, in these kinds of questions, you're looking for the vaguest answer possible. At least is really what you're looking for, because you can prove that there is a certain amount, but then there might be more that you don't know about, but that's okay because at least means you meet the minimum. So you're really just looking for kind of the vaguest answers in all these. So that was the end of it. Kind of list of topics that I was told to cover at the end of this video. So important. So these questions, like I said, are not the most critical questions of shapes of curves that you need to know. Please make sure to check out those other videos. Hopefully they explain a little bit better than I do, and they'll definitely review the rules better than I do. But I'm going to so on the AP exam, if you're watching these because you're taking AP Calculus, there's going to be one problem that's kind of like the problems which are like 3 and 4. 3 and 4 problems are the ones that you have the tables, and you have to approximate f prime and narrow down which table is which. There's probably going to be one of those, and there's also going to be one problem that's like 5 or 6, which is the possible, not possible. Remember, you draw the graph. It's possible one way, it's not possible the other way. It's going to be one like those. And then there's probably going to be one of, as I call them, the stupid questions. I shouldn't call them that. I'm sorry. But these, you're given these charts and you have to figure out which statements can possibly be true. So that's kind of the breakdown of what's going to be on the exam. This is definitely not going to be like a free response question. As you can see, they're literally all written out on multiple choice on the worksheet. So, but that is kind of all I have. Thank you guys for watching. If you have any questions, drop them in the comments. And please keep watching Memphis Communiversity. I hope they're really helping you guys. All right, have a great day.